So for our last and final lesson of this particular unit, we're going to be looking at the derivatives of trig functions. And once again, they're shortcuts. These are just some things that you just need to know how to do and how to use. And so here are the derivatives. And let me make that a little bit bigger. Okay. So the derivative of cosine of a function is negative sine of u. And for the time being, I want us just to ignore this u prime stuff because this has something to do with something that we haven't talked about. In my rearranging of my lessons, I should have taken this off. But here we have the cosine of u is the opposite of sine of u. The derivative of sine of u is cosine of u. The derivative of tangent of u, and that can be x. Let's just change all these to x's. The derivative of sine of x, cosine of x is negative sine of x. The derivative of sine of x is cosine of x. And the derivative of tangent of x, excuse me, is secant squared of x. Okay? And then secant of u, actually secant of x will be, the derivative is secant x times tangent of x. Cosecant of x is the opposite of cosecant x, cotangent x. And then the derivative of cotangent of x will be the opposite of cosecant squared of x. So we'll kind of clear that up as we go through some of these examples. But here we have y equals x squared times sine of x. Notice that x squared and sine of x are being multiplied. So we actually have to use the product rule for finding the derivative of y prime. Okay, so I'm going to let the first term be u, and I'm going to let sine be v. So the derivative y prime is u, which is x squared, times v prime. So what is the derivative of sine of x? Well, derivative of sine of x is cosine of x. So cosine of x, and then the product rule says we have to add v, which is sine of x, multiply that by u prime, which is 2x. So this is u v prime plus v u prime. And then cleaning this up just a little would give us x squared cosine of x plus, I like to put the 2x in front, 2x sine of x. And that's your derivative. Okay, so don't forget that if v is sine of x, then v prime is going to be, the derivative of sine is cosine. So cosine of x. So it's just a matter of finding derivatives using our tools that we've learned over the course of this unit. All right, so let's find the derivative of y prime, or of y. So y prime equals, this is a quotient. We have a numerator and a denominator. So we want to use the quotient rule. The quotient rule is low 1 minus sine of x. Well, that's not an I, but anyway. 1 minus sine of x times the derivative of high, and the derivative of cosine is negative sine of x. So I have low d high. I need to subtract high cosine of x times the derivative of low. Now what's the derivative of 1? Well, that's 0. I have this negative here. What is the derivative of sine? Well, the derivative of sine is cosine. So now I have to multiply cosine of x with negative cosine of x. All right, and now, we got some cleaning up to do. So in these two terms, I need to distribute 1 times the negative sine of x is negative sine of x, and negative sine of x times negative sine of x is positive sine of x squared, or sine squared x. We learned that in trig. And then what about negative, okay, this is subtraction, so cosine of x times negative cosine of x is going to be negative cosine squared x, and then I can change that to addition. So I have negative sine of x plus sine squared x, and then this changes to plus cosine squared x. So here's your derivative. But I'm wondering if any of you happen to see anything that we can do to clean this up a little bit. What do you notice? What do you remember about sine squared x plus cosine squared x? That's an identity. This is a trig identity, and that is 1. So I have negative sine of x plus 1, and prettier, I think, is 1 minus sine of x. So remember, this is an identity that equals 1. All right. Okay, now let's move on to another example. Here we have y equals secant of x times 2x to the third. So this needs to be a product rule. Okay, so y prime will be u, which is secant of x, times the derivative of v, which will be, what, 6x squared, plus v, which is 2x cubed, times the derivative of secant. Okay, well, the derivative of secant, remember, is secant of x tangent of x. So let me scoot that up a little bit. My fingernails are dirty from those markers. Okay, sorry, I digressed. Okay, so I have u dv plus v, and the derivative of secant of x is secant of x times tangent of x. And then if there's any cleaning up to be done, I like to put the 6x squared secant of x in the front plus 2x cubed secant x times tangent of x. And there's your derivative. So these are formulas that you need to know how and when to use. You need to know them, and you need to know how and when to use those derivative formulas. All right, this example, we have a quotient. So we need to use the quotient rule. So y prime equals low, which is x squared minus 9, times the derivative of high. And the derivative of tangent is secant squared x. So I've got x squared minus 9 times secant squared x. That was low. This is derivative of high, minus high times the derivative of low, and that's all over x squared minus 9. Okay, so really, I think the only real cleanup that we need to do is I will distribute, and I have x squared secant squared x minus 9 secant squared x minus 2x times tangent of x. And all of that is divided by, and I forgot to put this up there, x squared minus 9 squared over low. Okay, so it's just a matter of It's just a matter of using your formulas to find the derivative, and then these involving the trig functions, you have to just remember what the derivatives of the trig functions are. All right, couple more examples. Excuse me. Here we have a product, so we will use the product rule. And that is sine of x times the derivative of cosine. The derivative of cosine is sine. So it's sine of x times sine of x plus, so I have u times dv plus v, which is cosine of x, times the derivative of u, and the derivative of sine is cosine of x. And when we clean this up, we get sine squared x plus cosine squared x, and we had something very similar earlier. That's an identity. Sine squared x plus cosine squared x is equal to 1. And as I like to say, cosine squared plus sine squared equals 1. Again, this is an identity. Okay? All right, and one more, and we'll wrap this lesson up, which will then wrap up the unit. Okay, so again, I have a product. So y prime equals secant, which is first, or the u, so it's secant of x, times the derivative of tangent. Derivative of tangent is secant squared x. So I have u dv plus v, which is tangent of x, times, let me see where I am, u dv plus v, and I need du. The derivative of secant is secant x tangent x. Kind of ran out of room there. So y prime equals, this is going to be secant cubed x plus secant x tangent squared x. I'm thinking that there might be an identity. I'm gonna have to think about that a minute. These two terms have a secant that is common, and it's secant. When I factor the secant out, I'm left with secant squared x plus tangent squared x. And I'm pretty sure that equals 1. So I believe that is an identity that equals 1. So my ultimate derivative is going to be y prime equals secant of x. Now, I need to check on that. I need to make sure of that. I'm not, for some reason, I've got to verify that. But anyway, I'll get back with you on that. This is using your derivatives of trig functions with the other tools that you have in regards to finding derivatives. So I will zoom out of this, and that will conclude this lesson.